In this video, we'll see how to use WebAssign technology to find p-values. Over on the left-hand side of the screen, we have all the distributions of interest. In this case, we will look at the normal distribution. The first thing we look at is area. The area, according to our p-value, is what we shade according to our rejection region. So if we choose area in the left on WebAssign, that is indicated by a lower-tailed test. If we choose right in WebAssign, that is our upper-tailed test. If we choose two-tailed, it is our two-tailed test of does not equal to. These are all located in our alternative hypothesis in our study. Let's start with an example of an upper-tailed test. To find a p-value for an upper-tailed test, we start with the test statistic on our axis. So the test statistic could be positive 1.86. 1.86 is the z-test statistic. So in WebAssign, we enter that into our z-score of 1.86. Once we enter that z-score, it gives us a probability. It says the probability in this upper tail is 0.031443. That is our p-value for this example. Let's take a second example of a lower-tailed test. For a lower-tailed test, we shade the left part of our curve. But I also need to change in WebAssign to the left tail. Consider a z-score of negative 1.69. I enter negative 1.69 into the z-score area, negative 1.69. It gives us the corresponding probability, which is the area in the tail, of 0.045514. If we had a two-tailed test, let's use the same example. Well, in a two-tailed test, we know there are two tail areas. The area in the left is also the area in the right. So when I change the area on WebAssign to two-tail, it should just be 0.0455 times 2. And if we do just that, change to two-tail, we do end up with a p-value of 0.091028, which is just double of the area in the left tail from before. Then we can use these p-values to make our decision by comparing the p-value to alpha. Whenever our p-value is less than or equal to alpha, we reject our null hypothesis.